All right. Well, hi everyone. I'm Eric, and I'm leading the 1 week data science team. So this past week, we've been working on a data dashboard, analyzing the statistics and trends in a Spotify 200 data set. And I'll leave it to my students to talk about it. So before we start, unfortunately, one of my students is not here. They had to leave early. And my group of students is already like small. We only have we're just a group of three, so it'll just be us two presenting and me helping along. So whenever you're ready, Shubh, go ahead.
Okay. The data set we are using for our dashboard, Spotify Top 200 charts. We are using this data set to see how different variables in the top 200 songs on Spotify affect how popular those songs are. The songs on the top 200 are there for a reason, and we are using this data set to dig deeper into why those songs are there. The popularity of songs can be measured in multiple ways, either through a popularity scoring scored through 0 through 100, determined by Spotify, or the number of streams the song gets on the platform.
So this figure here made by another student that had to leave early, so I'll be presenting it. The chord or key of a song represents the musical scale the song was written in. This bar chart displays the total streams listed in each chord. So this figure shows that the most popular chord is C sharp slash D flat, and the least popular is D sharp slash E flat. The other chords have total streams that range from 650 million to 910 million total streams. The sum of the streams may reflect that the total number of songs released in each chord, so the stream rate per chord will be analyzed. So this is the stream rate. This bar chart, this is the bar chart of the average streams per song of each chord. And the chords are ordered by the total number of streams in the previous figure. So while the previous figure showed that the C sharp D flat had the highest total streams and the D sharp E flat had the lowest total streams, the stream rate has a different distribution than the previous figure. So according to this distribution, it appears that the songs written in D sharp E flat have the highest stream rate, while the others have a similar rate, similar but lower than the D sharp E flat. And then this right here is a multi-box plot that compares the amount of followers an artist has and the number of streams each song gets. The streams in the Spotify 200 charts range from around 4 million to 10 million streams. The median and third quartile stream for artists who have a following of greater than 40 million are the highest. And there are outliers for the groups of followers, for the group of artists with fewer followers, but the inner quartile ranges are smaller and less than the 40 million group. This supports that artists with a larger following receive the most streams.
Loudness measures the volume of a song using a relative scale made by Spotify. In this scale, the loudest songs are positive and the quietest songs are negative. This multi-box plot compares a song's popularity to its loudness. Most songs have a loudness from -15 to 5. From -15 to 5 have a median popularity of 72. However, there is a drop in popularity when the loudness is less than -15. This supports that the middle volume and loud volume songs are the most popular. This multi-box plot compares the number of artists followers to popularity. The artist with a larger follower count have a higher popularity score compared to artists with a following greater than 40 million. While artists with lots of followers do get more streams, those streams are listened to over a longer period of time. Artists with fewer followers get streams very fast, which most likely results in their songs having a higher popularity score. This may reflect that artists with a lower following have a larger audience growth rate than artists with a large following.
All right, so this next figure is a heat density map of valence versus popularity score. An important part of the song industry and for music consumers is the way that a song or album evokes a sense of happiness or contrarily sadness. Thankfully, there is a metric called valence, which rates the positiveness of a song on a score on a scale of 0 to 1, where 1 is the most bright and joyful. Using this metric, the density map above compares the valence score of a song to its determined popularity score. The diagram shows a high density where the valence is from 0.3 to 0.7, and where the popularity is from 70 to 80. This means that for songs that people generally like, around a popularity score of 70, more people gravitate towards a midway valence score. These songs are not too happy or sad, but rather a more neutral standpoint, as proven by its valence. This bar chart shows the sum of streams per month. As shown in the figure, the most streams occurred in late spring to early summer. Beginning in August, the total number of streams decreases and steadily rises until February. While it may appear that certain months are more popular for streaming, an important factor to consider is the number of songs released in each month. In the next figure, the average streams per song in each month is investigated. The main issue with the previous figure was that if a month happened to have more songs released in that time period, then it was more likely that the sum of streams for that month would be greater. It is possible the number of songs in a month interfered with the objective popularity of songs released in that month. To solve this issue, the current figure shows the average number of songs a song receives in the dataset, instead of the sum of streams. The result of this graph illustrates that December, May, June, and November are actually the top 4 months in which songs receive the most streams. This means that songs released in these months are more likely to be popular. This dashboard has found insights related to the popularity of songs in Spotify's top 200 charts. The most important factors in a song's popularity are what time of year it is produced, the loudness of the song, and the valence of the song. The chord stream rate is mostly constant, except for the D sharp E flat chord, while it had the highest stream rate. The artist followers study shows conflicting information that the artists with more followers have higher stream rates, yet they have the lowest popularity score. One additional explanation for the gap between the total streams and popularity score could result from the different kinds of followers that artists have. Larger artists may have lower popularity score because a portion of their followers only listen to them because other people do. So when it comes to a new song coming out from one of the top artists, these followers may be less incentivized to actually play the music. On the other hand, smaller artists probably have more devout followers that are likely to click on their new song right away and cause a popularity surge. In the past few years, COVID and especially the global quarantine has affected everybody in different ways. One thing everyone experienced in the recent past is spending more time alone. And one of the best ways to ease the boredom is listening to music. Music never fails to change the mood and brighten anyone's day, but sometimes finding the right music can be a challenge. However, using this dashboard's metrics on popularity can help to find the right songs. Whether it be through certain chords, artist followers, or valence, these metrics can help you find the songs that everybody else is enjoying. Thank you for listening.